So last time we talked about the fourth example of the trigonometric equation, and we try to solve the cosine x equal to a. So when a is between the -1 and 1, first you may find the inverse cosine of a. So we know this inverse cosine of a is between the 0 and the pi, right? Because the range of the inverse cosine function is from the 0 and pi. And then after you find this inverse cosine a, you can find another solution to this equation between the 0 and 2 pi. Let me show you here. So for example, for this equation, cosine x equal to -1/2. First, we can find cosine inverse of -1/2, and we know this is equal to 5 pi over 6, right? And after you find this special solution to this equation, you can also find another special solution to this equation between the 0 and 2 pi. Let me first sketch this angle in this rectangular plane. So 5 pi over 6 is about here. Okay, so this is the 5 pi over 6. And then you may use the 2 pi minus this inverse cosine of the -1/2 to find another special solution to this equation. So this is 2 pi minus 5 pi over 6, and that is the, okay, so 12 minus 5, you have the 7. So it's 7 pi over 6. Actually, is this angle. Okay. And from this graph, we can also easily locate this angle, this second solution, because if we draw the vertical line through this point, then we can find the two terminal points on this unit circle whose x coordinate is equal to -1/2. So this guy here is equal to, the x coordinate is equal to -1/2, and this guy also equal to -1/2. Okay, here this graph is kind of distorted, so does not show the true picture. And then this angle, let me use the blue color. So this guy is 2 pi minus 5 pi over 6. So that is a 7 pi over 6. And I can also obtain this 7 pi over 6 by pi plus the pi over 6, right? Because this angle and this angle are both the pi over 6. So in this way, you find the two special solutions to this equation, cosine x equal to -1/2. So after you find these two special solutions, then you can add the multiple of 2 pi to these two special solutions to get the general solution. So the solution set is a set of x. Either x is equal to this first special solution plus the 2k pi, or x equal to 2 pi minus this special solution plus 2k pi. So this is the case when the a is between the -1 and 1. And we also deal with the other special case when the a is equal to 1, 0, and -1, right? So for example, when the a is equal to 1, then you have the solution x equal to 2k pi. And when the a is equal to 0, you have the solution equal to the half pi plus k pi. And when the a is equal to -1, you have the solution x is equal to pi plus the 2k pi. And when the absolute value of a is greater than 1, no solution, because the range of the cosine x is between the -1 and the 1. So that means the absolute value of the cosine x must be must be less than or equal to 1, cannot be greater than 1. If a is greater than 1, its absolute value is greater than 1, then this cosine x equal to a has no solution. So this is the case of the cosine x equal to a. Now, we will look at the trigonometric equation involving sine x. And let's look at the page 567, and we try to solve the problem 16. So we have the sine x equal to negative root of 3 over 2. So this is a section 6.6. Right, we'll continue to talk about the trigonometric equation. So now let's go to the page 567, and let's look at the problem 16. So we try to solve this equation involving sine function. And before we try to solve this equation, we can first draw the unit circle in the rectangular plane, and this can help us to find the 2 or the 1 special solutions between the 0 and 2 pi. So you draw the rectangular plane, and then you also draw the unit circle. Not so wrong. Let me draw it. Okay, this is my unit circle. And we know to find the solution to this equation is to find the terminal point on this unit circle whose y coordinate is equal to negative root of 3 over 2. So let's try to find the point with the negative root of 3 over 2 as the y coordinate. So negative root of 3 over 2 is about here, right? Then you can draw one line through this point, okay? And then this line, this equation is the y equal to negative root of 3 over 2, and it intersects this unit circle at these 2 points. So that means these 2 points are the terminal points whose y coordinate is equal to negative root of 3 over 2. So then we can first find this angle. So actually, this angle can be obtained by using the inverse sine function. So we find the first angle, first special solution, that is the sine inverse of the negative root of 3 over 2. What is this angle? Yeah, what is the inverse sine of the negative root of 3 over 2? First tell me, okay, what is the range of the inverse sine? Range of the inverse sine is equal to what? Negative half pi, right? To half pi. Okay. And then what is this angle? Pi over what? Pi over 3, but it's negative, right? It's the negative pi over 3. Okay? So first we find this angle. So this angle here, this is the negative pi over 3. But we prefer to the positive angle. So we need to find the smallest positive angle which is coterminal with this angle. So that is, we just add the 2 pi to this angle, then we get the smallest positive angle which is coterminal with this angle, right? So now we add the 2 pi to this negative angle, and then we get, okay, so this is the 6 pi minus pi over 3, so that is the 5 pi over 3.